Okay, I'm making a micro video about the simulation. It does work really well. I'm telling you, it works really well. But I was trying to make sure that the LED is not going to be turned on with higher, too much current. Because remember, the LED will turn on after 5 milliamps of power consumption. Actually, the current that is going to feed the LED. So I had to change the upper part of the resistor that feed the emitter of the transistor, because we don't want this LED to be blow up. Because one example at this, I think 5.66 milliamps should be just fine for the LED to be turned on, but before it was 3.3K. So I saw that it has more than 50 milliamps. That is not really good for the LED. It might blow up the LED, or it might be way too bright. So one example, I'm going to turn on the simulation. Let me close the switch. One example. This is off right now, as you can see. The LED is off because the fuse is basically still on functionality of the fuse is on. So right now I just placed the switch, just sort of like a simulate like the fuse blow up, and it's not feeding the circuit anymore. So basically, let's do that. I'm going to press the letter A. You will see the current that travels to the LED. Let me show you. You can see it goes higher than what it's supposed to be. 15.2 milliamps is too much for the LED. It might blow up the LED, or it might be too bright, or it's not gonna withstand that amount of current. So we got 15.2 milliamps. So I think the best choice is here is to have this as 10K resistor. So the current that is going to feed the LED is not that high. So that's the thing, to make sure the LED is not going to suffer. The other components, they are fine. The other components, they do not drain that much current. It's perfect. So one example, we got okay, we had the LED is off right now because the simulation of the fuse blow up is not enabled yet. So this is just a simulation. So right now I'm going to open the fuse. Basically, this is sort of like the fuse. I'm gonna open right now, and you can see the milliamps DC current. We have 5.66 milliamps. It might be way too bright. It might be way too bright for the LED, depending on what type of LED you're gonna purchase. We gotta find out the LED with how much current is going to drain that particular LED. Well, okay, we had 5.66 milliamps. Let me see how much voltage we have on this. We have here, oh yeah, we got 1.76 volts. So let me increase the size of this window so you can see it. All right, the LED is the consumption voltage DC is 1.76 volts, feeding the LED. So we have 5.66 milliamps. That's good enough for the LED to be turned on. So the R emitter right here should be 10K, not 3.3K, because we want the component to be able to function properly without overheating and stuff like that. So the 100K, sorry about that, the 100K resistor, they're fine. They do not consume that much current. One example, let me see here, we had 42.7 microamps. That's perfect right there. And we have here the diode, sorry about that, is we have negative 8.54 picoamps. This is the diode. I had to change the diode. I was looking for the component in particular. I was a bit I was amazed a little bit. So this diode is this one here. I'll be like, what the hell? But it's okay, man. It's okay. Don't worry about it. All right, so I gotta figure out how to place those components here. So I need, so it's going to be 10 components for each individual rail. I mean, sorry about that. 5 components for each individual fuse as a indicator of fuse failure, or fuse is open. Basically the fuse is open. So that's a good idea. I had to do the same thing with the other. It's okay, I can fix it. So don't worry about it. Just double click to it and change the value to 10K, so the LED will not be suffer from excess current. So we want a particular LED to be function properly without overheating or blow up, because we need only a few milliamps of current to feed that particular. Let me check the other ones. I think that I had the same situation here. We had the 10K. We had the switch to be open or closed to simulate that the fuse is open, like I already mentioned that many times. So okay, I'm going to turn on the simulation. I'm going to press the letter C to see. Okay, you can see it's good. The LED is on. Let me see how much current is feeding this. Okay, this is a little higher. This is 6.62 milliamps. It's a little higher. That's what I noticed here. 6.62 milliamps. So let me increase the size of this yellow window so you can see it. Okay, we got 6.62 milliamp. Might be way too bright. We may be way too bright. So we need to control the current here. It's a little bit different. Let me see the other one. Okay, we are everything is correct here. I gotta see the other one. Okay, let me turn on the simulation. Okay, picoamps. Okay, because I have not enabled the fuse blow up. All right, let's see the letter D. So okay, we got. Let me see. We got 6.61 milliamps. It's a little higher. That's a little weird. It's a little higher. That's a little weird. Let me see. Did I change the LED current? No, it's the same. 5 milliamps. We got 5 milliamps. So it's a little higher on the negative rail. It's weird. Maybe we can try with 12K just to be sure. 12K. I just dropped numbers there. I mean, there is some calculation that you can actually do, but stuff like that. There is formulas and stuff like that. But I really don't want to waste time doing that. Just drop the number there and that's it. And then try by error. Let me see. 12K. Let me see. 12K. Okay, 12K. We got 5.61 milliamps. So I think 12K should be just fine for the bottom part of the rail, negative rail from the power supply. So it's feeding 5.61 milliamps. Maybe it's going to be way too bright for the LED. We don't need the LED to be way too bright. So we need to control. Yeah, I'm uploading this video today, and this is going to be part 5. This is part 4. So I gotta make another video. So all right, so I'm gonna publish this one right now, and then upload this video that I'm making right now, just to be sure, tweaking everything the best we can. So I gotta find information about the LEDs current consumption, so we don't want that LED to be too bright, like I say. So let's check for the LEDs. I was looking for the cap. Okay, we already had the part number for the capacitor. So oh yes, I have to also do that. I need to identify each individual capacitor with the part number. So this one is 10 nanofarad, 0.01 microfarad. So this C3. Okay, C3. So it's easy to do at least. Oh, let's see. Hold on. Give me a sec. I needed the. Okay, the cathodes are these two. Okay, so C4 is this one here. Component. Okay, C4. All right, visible. And then we need the value is 0.01 microfarad. I need to find the part number too. So this one is 7.5 millimeter pitch distance. There you go. All right, cool. For now, I'm gonna give that information. Oh yeah, I forgot to move the identification of the capacitor. So we know it's 10 nanofarad. Yeah, I should place the value on the PCB too. I think it's fine. I think I can do that later. All right, we got that one there, and we need the other. The other one is, it goes to the positive. The other one is C6. This is C6, so we need to do the identification. That's really important. And this is a 10,000 picofarad or 0.01 microfarad or 10 nanofarad. So that's the thing there. All right, we got this ready to go. I should write down the voltage. So it's 7.5 millimeter pitch distance. So we got that. And then I will continue doing all the identification, the proper component identification. So we got everything squared out, good to go. But this is really important to do. So the bottom one is C5. Okay, this is C5. You just gotta be sure that everything is good here. Oh yeah, I gotta move some stuff here. You can see that I gotta keep looking if everything is aligned correctly. So that's the other thing that I gotta do also. C5. Let's go with the C5. Pitch distance 7.5, 0.01 microfarad, and this is C5. Visible. There you go. That's the component right there. There you go. Then let me do one more time, and I think the values. I think on the simulation. So I can continue doing that. Let me save it. So to go back to the simulation. All right. I think those values for the receipt, they should be 2K, 12K. Sorry about that. 12K. All of them. I think so. But the problem is when I change it here to 12K, I noticed that the LED will not turn on for some reason. Let me try one more time. Let me see. Okay, let me enable the letter A. Let me see. Okay, it's off. I'm gonna press the letter A. Let me see. I just need to see. It's still off. Yeah. Okay. It's not on yet. The LED. We got 4.77 milliamps, so it's not enough. It's not enough to turn on the LED. So I think 10K is the proper value for the. As you see, it's 5.60 something milliamps. Okay. Depending on the LED, maybe the LED that we choose might be the one that's depending on the LED, the component part number. All right, so I gotta continue here. I'm gonna continue later another video. So let me do one more identification. So let's do this one is C3PO. All right, let's do that. Component. Okay. This is capital letter C3, visible, and this is 0.01 microfarad. This one is pitch distance. It's already 7.5. There you go. And then I'm going to move the thing. We know that it's 0.01 microfarad or 10 nanofarad or 10,000 picofarad. 10,000 picofarads. Okay, so it's good to go. All right, I'm going to continue working with this. I gotta figure out about all the stuff on the simulation. And I think the bottom one should be 12K and the top should be 10K. So we don't want the LED to be blow up or burn out. So let me hold on. Before I stop the video, like I always say, I think I should use Handbraker to shrink the video file so I can upload it right away. Okay, the LED discrete. Okay. All right. Let's see the LED. Ahora, podrías colaborar como ser un. There is I really had to apologize for the other friends from Latin America. They asked me for favors and stuff like that, but it's kind of like way too difficult for me to do that right now. It's way too difficult. I'm trying to do my best to give the best information out there. Okay, we got 5 milliamps here, or maybe you can get a little higher just to be sure. 5 milliamps. I think this default should be 5 milliamps of current. So through hole devices, and pitch distance should be 2.54. I think. Let me see. We got a pitch. Okay, through hole. It doesn't say nothing about it. Dimensions. We can use. The color is okay. You can choose whatever color is depending on your taste. Diffuse. It has to be diffuse. Diffuse and not clear. Oh, they don't. What? Really? No diffuse? Really? Really? Okay, let's clear here. Okay, 646 in stock, 646 remaining. Apply filter. All right. Oh yeah, I should. Oh yeah, it's okay. Don't worry. All right, let me see. We have this LED. I think it's too big, but it's okay. Oh, this is fine. This one is fine. We got the red and green. Or it can be another color. We just need to the data, the information. Okay, we had current test 20 milliamps. Okay, I feel you. 20 milliamps maximum current test, and we had 15. Okay, I understand why he did that. Mr. Stewart did that. Okay, got it. 20 milliamps. All right, let's see. Let me see the information here. Red source color device are made with whatever general purpose LED, low power consumption. This is the information. The diameter, okay, 5.9. Okay, we got that. 2.54 millimeter pitch distance. So it consumes maximum is 20 milliamps. DC forward current 30 milliamps. 75 milliwatts. So we don't want that LED to be way too bright. Yeah, you know that's the idea. To control the brightness of the LED. Okay, so it's maximum 20 milliamps, and he had it at 3K. Oh, let's see. 3.3K. Tolerance. Okay, let me see. Current, let me see. Let me open the switch. Okay. 15.2 milliamps. Maximum current consumption is 20 milliamps tested, but it might be way too bright. That's depending on the situation. I think you can go with the let's say, what about 5K? 5K, just to have a balance there. 5K. Let me see. 10.6 milliamp. I think 5K should be just fine with this design. 5K. We don't want this LED to be way too bright. I think that's 10.6 milliamps should be just fine. Or maybe it's too bright. So the maximum current is 20 milliamps. Voltage forward 2 volts. Okay. 20 milliamps. I think we can choose because decisions. The voltage that we have is, let me see the voltage. Sorry about that. We have 1.79 volts. Almost close. If we have 3K, 3.3K, let's see. 1.80, almost 1.80. We have 15.2 milliamps. I think the 3.3K. I think he's right. Yeah, he's right. So that should be, it should be this LED, and then the one that I choose, it was tested to 20 milliamps, 2 volts, discrete, 2 volt radio. Okay. I think this is the one. 2-volt, 20 milliamps. Okay, I'm gonna get this part number, and then I wanna save it here. Okay. This requires a lot of thinking, you know, because we don't want the LED to be way too bright. That's a good thing to think about that. You know, think about that. We don't want that LED to be way too bright. It's 15 milliamps, so it's going to be a bright, really bright LED after it's on the LED. So this is the LED. This is the LED red. LED red. Okay. Depending on the color, I mean, we need to have that particular component. Does not matter the color. You can choose whatever color you want. I mean, on the design, you can choose whatever color. It can be red for the right channel and green for the left channel, or whatever color. It's okay. At least we know which one it is. So we have the green one that is the same part number. You can see it's the same one, but it's green. It's about the same one. Yeah, you see the same information. Oh, this is different. Oh, one says 2.2 volts, the other one says 2 volts. So that means that they are different. I gotta look for the correct one. So this one, the red one, consumes 2 volts. So we need to find another one that consumes the same thing. So it has to be green or another color. So okay, got it. Not to get confused, so we need one that is 2 volts, 20 milliamps. The current test. 2 volts, 20 milliamps. Okay, so this one is 2 volts, 20 milliamps. Miliamperes en español, por supuesto. So this guy, depending on the color you want to choose from. So we need to have the value, the component value. That's it. Specification of that particular component. That's it. All right, so we got that figured out. I think 3.3K. I thought that I had to change it, so I think 50 milliamp is not gonna blow up the LED, so it's good to go. So let me change this back the way it was. I thought I have to change. Maybe you can experiment with that. You don't want the LED to be way too bright, so you just want it to be on. Or maybe it's on but it's too weak, so I think it's the best choice to leave it as it is. Let me see how much current this one will is feeding this LED, the bottom one. Let me see. 18.8 milliamps. So the bottom one is going to be brighter. It's brighter than the top one. It's almost 20. We got 18.8 milliamps. So we gotta work with this. 18.8. So the bottom one is going to be brighter. Okay, I see. Okay, depends on the situation right there. Okay, so now what I'm going to do on the PCB, I'm just going to leave the component identification but not the value. The value is up to the builder, so it's not going to be enabled on the PCB. So you can choose whatever value you think is best choice for the LED to be bright. So okay, now I gotta look for the component. Let me see what transistor. Oh, okay, I think I have it. Okay, I got it. Let me look for that one. Let me save it here. This is the information. Okay, good to go. The LED I had to change it because it just, I'm not sure why he chose that one for some reason. It's funny. Yeah, this is I'll be like, what the hell is going on here? It's funny. It's just funny. It's okay. Don't worry about that. I just choose this one here, the N1N4007. It's a really common diode to use there. Or maybe it's too big for this application. I'm not sure. Maybe it's not really needed to be. Let's try the other one. One sample. Let me try. I'm gonna use a different type of diode. Switching diode 1N4148. Let's try that one to see if the circuit is still working. It's a switch mode diode. Let's see. Okay, gonna enable the simulation. Okay, still off. I'm gonna press the letter B on the keyboard, and it's on. So it's still working. So it's still working really good. Look at that. So let's see how much current consumption this one will have. 7.28 milliamps, picoamps. Sorry about that. Picoamps. And here we got 108 microamps. This one here, 15.2 milliamps of consumption, and this one here, 15. I'm sorry about that. I should make it larger so you guys can see better that. So, okay, let me put the window one more time, and I'm going to increase the window so you guys can see it better. Okay, we have it here. Okay, we have 15.1 milliamps consumption from the LED. It's good because we know that it's 20 milliamps maximum current, so it's going to be bright. It's going to be bright. We had that one. We had the resistor 100K, 108 microamps. We had the cathode is negative 7.28 picoamps, and we had this one here is, oh yeah, that's the consumption, 7.28 picoamps, and this one here 15.2 milliamps. Okay, good, very good. So that's making sure that the consumption of the LED is not going to be affected. That's a good thing. That's what I call thinking through the design. All right, so it's good. 3.3K. I think we can change it to 1N4148. It should work fine. I think this is way too rugged for that application because the 1N4148 is a small glass type diode. I think it's the best choice for this design. So let's start one more time. Let me see, just to be sure. Okay, press the letter B. That means that the fuse is properly function. It's not open. Then I'm gonna open the key, letter B. All right, and it's pretty fast. As you can see, the action is pretty fast. All right, good. So I think this should be 1N4148. Let's change those switching diode, and they are smaller. They are easy to get. They're pretty fast. Let's do that. Switching diode 1N4148. Okay, switching diode. They're going to be faster, I think. All right, let me save it. 3.3K is good. So the LED should be. Let me write down that information here. Okay. Let me write it down here. The information that's pretty important right there. Paste red is 2 volt, 20 milliamps of consumption from the LED. That's really important. All right, guys, I'm gonna stop the video. I think this is part 4. I hope you like this video. I will continue making one more after I continue working with this takes time, and it's not like one sample. It's not like okay, I got this schematic, I'm just gonna throw the components to the PCB and make it say it's done. It's not like that. You gotta think about the components, how much power they require, the current that is going to travel throughout the passive components. It's a lot of thinking. It's not like okay, I'm just gonna throw the circuit right there and make it say it's done. It's make it happen. It's, you know, it's not like that. And also I gotta give it some space. At least I have this space to place the components, and I gotta figure out how to connect them each between them. So it takes time. It takes time. At least I have this already. That took me a long time, like I say. And yeah, I gotta keep identify the other component. All right, guys, have a good day. I hope you like this video. This might be way too long. All right, guys, have a good day. I say like 3 times. Sorry, I'm sorry about that.